Greetings and welcome, friends. We're taking a look at Prac2.3. We were talking about matrices yesterday. And we also talked about when they're equal, that they have to be the same size and their corresponding elements equal, and also how to add and subtract them and scalar multiply them, all sorts of stuff like that. So here's question 1, and it asked, find the values for x and y for which the following matrices would be equal. So here I've got a, what's the size of this first matrix, by the way? How many rows does it have?
2 by 1, bro.
Yeah, it's a 2 rows, 1 column, 2 by 1, and it's equal to a 2 by 1. So even though this has this whole top thing right here is all one element there, so don't let that fool you. So if these matrices are equal, these 2 by 1 matrices, then their corresponding elements must be equal. So therefore, x must equal 2y minus 4, and y must equal 2x. And now I can just solve this like it's a system, right? Because those are going to have to be true together, sort of thing. And it looks like this one's solved for x, this one's solved for y. I probably should just use substitution, right? Probably. So let's do that. I don't know which one you want to substitute for what. Let's see if this is what y is equal to. Let's plug that in there and solve. I'll get x equals 2 times 2x minus 4. And I'll simplify x equals 4x minus 4. We'll bring the x's together, of course, just solving this equation for the remaining variable that we have. So negative 3x equals negative 4. And then we'll divide by a negative. Don't forget to flip your equal sign. That'd be a shame to forget that. So x equals positive 4/3 is the value of x. How do I find the corresponding value for y? Plug it in, and hey, why not plug it into our revised equation, even though it was unrevised since it was pre-solved for that. So y equals 2 times the value of x is 4/3, so that's y equals 8/3. So our solution is 4/3, 8/3. As you see, the answer was selected there. Bam. Right? So that's the value of x and y that make these equations true, which makes those matrices equal. All right, so that's the idea. So scrolling on down, then there was a second set of problems. It said use matrices A, B, and C to find each sum, difference, or product. And problem 4 was a difference. It said matrix A minus matrix B. Now, what is the size of matrix A?
3 by
3 by 3. And matrix B is a 3 by 3. And since they're the same size, I can, in fact, subtract their elements. So A minus B, what size is my answer matrix going to be? 3 by 3 makes sense. So let's see, for A minus B, I'll have negative 1 minus 2. Oh, what the heck, I'll write this down. I'll have 5 minus 3. I'll have 6 minus 1 for my first row. Then I'll have 2 minus negative 1. I'll have negative 7 minus 1. I'll have negative 2 minus 4. And then we'll have 4 minus 5. 4 minus a negative 2. Careful with that double negs, friend. And 2 minus 3. So A minus B is equal to, well, we just have to simplify all of these. So that's going to be negative 3, positive 2, positive 5. 2 minus a negative 1 is 2 plus 1, which is 3. Negative 8, negative 6, negative 1, positive 6, and negative 1. So this is our answer. Notice that matrices are bracketed by little square brackets. Don't forget that. That's important. And just as a follow-up question, if I call this, I don't know, matrix D or something like this. If I call this matrix D, what would element D sub 2, 3 be equal to?
negative 6.
Right, second row, third column would be at the negative 6, right? So I just want to make sure you're able to locate the elements like so. But thanks for watching, friends. Have a great day. Bye-bye.